Good day everyone, thank you for joining us today. I'm Dr. James Alexander Joseph, from the Lex Medical Research Center, and I'm here to present our latest findings on a pressing issue we're calling malaria. This presentation dives into alarming observations we've made over the past 5 months, connecting toxic fog reports, abnormal blood microscopy findings, and potential links to malaria-like organisms. Let's get started. Over the past 5 months, people across the country have been sharing images of toxic fog on social media. At the same time, our team at Lex Medical Research Center has observed a disturbing trend. Live microscopy analysis of blood samples has become increasingly difficult to interpret. In 100% of our patients, we're seeing abnormalities that are worsening. Most concerning, we've identified unidentified organisms in these samples that resemble various stages of malaria. We're deeply worried that these findings could lead to serious health issues, including blood oxygenation problems, wasting syndromes, and even death. Today, we're calling on laboratory scientists and experts to help us understand what we're seeing. Let's start with what healthy blood should look like. All blood samples in this presentation come from patients at our research center, analyzed and photographed by myself using live light microscopy. In healthy blood, red blood cells should not stick together, and there should be no unidentified organisms present. This is the baseline we compare against, and it's critical to understanding the abnormalities we're now observing. On September 28, 2024, we first noticed something unusual in a small portion of a blood sample under live light microscopy. The red blood cells showed strange characteristics we couldn't explain. Despite extensive searches in scientific literature and consultations with other experts, we found no answers. At the time, this was an isolated finding, but it marked the beginning of a troubling pattern. Fast forward to when reports of toxic fog began surfacing. That same unusual red blood cell finding we saw in September became widespread. Suddenly, it was common across our samples, accompanied by a rapid increase in unidentifiable organisms. Today, 100% of our patient participants show aggregated, disfigured red blood cells and these mysterious organisms. This escalation is alarming and demands urgent investigation. As we studied these unidentified organisms, we began to wonder, are we seeing different developmental stages of a single species, or just a random assortment of organisms? A chance encounter with a scientific article linking malaria and lupus prompted us to investigate malaria first. This hypothesis has guided our recent analyses, and it's where we've found some striking similarities. Malaria has been a scourge on humanity for centuries. The term itself, derived from the Italian mala-aria, or bad air, dates back to the 1740s, when it was thought to be caused by unwholesome air. This historical microphotograph from the late 1800s shows malaria parasites in blood, and it's one of the deadliest infectious diseases known. Could what we're seeing now be connected to this ancient foe? Interestingly, the symptoms we're observing don't match the classic severe symptoms of malaria. Instead, they resemble milder symptoms, like headaches and muscle aches, which are also seen in post-COVID syndrome. This overlap led us to question whether some cases of post-COVID syndrome might actually be related to a malaria-like condition. It's a hypothesis we're exploring cautiously. Before we dive deeper, let me clarify, our goal today is to spark an open discussion about what we're seeing under light microscopy and its potential connection to malaria. After analyzing over 100 blood sample images, we've noticed similarities between our unidentified organisms and Plasmodium ovale, a malaria species, at various developmental stages. We primarily use live light microscopy for blood rouleau screening, but these findings have pushed us to ask bigger questions. Let's look at the first stage we've identified, the ring phase. This is characterized by a single ring-shaped protrusion in an infected red blood cell, which becomes slightly oval and larger than normal. Notice the dense chromatin dot, or nucleus, bulging outward from the white ring of cytoplasm. This matches descriptions of early malaria infection stages. Next is the young trophozoite stage, from the Greek word for feeding. In the stained image, you'll see a deep purple cyst or dome shape in the center. The unstained image may also show a transparent dome upon close inspection. These features suggest the parasite is actively feeding within the red blood cell. Moving to the mature trophozoite, we see large dense chromatin dots covering the parasite. The infected red blood cell is slightly larger than normal, with jagged edges that are more visible with GMO stain. These characteristics are consistent with malaria's progression inside the host cell. The immature schizont stage is larger, with an amoeboid appearance and jagged edges. Both images we've included look remarkably similar, though we initially classified these as unidentifiable organisms. It was only later that we recognized them as potentially infected red blood cells, highlighting how challenging these findings are to interpret. In the mature schizont stage, fully formed merozoites appear as dark green spheres in one image and reddish-purple in another. These merozoites are the result of the parasite's replication within the red blood cell, preparing to burst and infect new cells. The gametocyte stage is the sexual phase of the parasite, where only a small percentage of schizonts mature into male and female gametes. These circulate in the bloodstream, ready to be taken up by a mosquito to continue the malaria life cycle. Most schizonts, however, rupture to release merozoites. In Plasmodium ovale infections, a ruptured schizont bursts open, releasing smaller merozoites into the bloodstream. These merozoites then infect other red blood cells, perpetuating the cycle of replication. This stage is critical to the spread of the infection within the host. Now, here's where things get even more complex. The image on the right shows synthetic self-assembled biocompatible gold nanoparticles. Notice how similar they look to the ruptured schizont images we just saw. With toxic fog and light-emitting nanoparticles being discussed in the media, we're forced to ask, are we seeing biological parasites, or could these be synthetic structures? This is a critical question we need help answering. Adding to the confusion, in 2021, a private company released genetically modified non-biting male mosquitoes designed to reduce harmful diseases by producing lethal female offspring. While the intent was to curb diseases like malaria, we have to wonder, could this have unintentionally influenced what we're seeing? We're not taking a stance, but we're raising the question for discussion. As we wrap up, let's address the big questions. Hydroxychloroquine and wormwood are first-line treatments for malaria and are also used for post-COVID syndrome. Could post-COVID syndrome actually be post-malaria syndrome? Are we dealing with a geoengineered form of malaria, and if so, will standard tests detect it? Will current treatments work? Could GMO mosquitoes have played a role in this crisis? Or are we completely off track, mistaking debris, contamination, or microplastics for something more sinister? Ultimately, we're seeking feedback from physicians, scientists, and researchers to ensure we reach accurate conclusions and develop safe, effective solutions. If you have expertise in microscopy, parasitology, or related fields, please reach out to collaborate. Together, we can address this urgent issue and protect public health. Thank you for your attention. I'm happy to take questions or discuss next steps.